So I know the ending of part 2 upset a lot of people, and I can't blame them. I mean, who in their right mind would leave an open corner joint like that? Why isn't it mitered? Well, I'll tell you why. The top of this cart is getting a drawer. Now, since I'm such a nice guy, I'm not going to simply attach this drawer to the cart. I'm going to throw this one away and make another one. Here's what I'm starting with. 3 pieces of 16 gauge mild steel, or 1 4/8 millimeters. Now that might not sound like a lot, but it's a little overkill for a drawer of this size. I'm throwing more material at it than it needs, and it's going to be a little harder to bend. But frankly, this is what I got. And please forgive me, but I've already gone ahead and cut them to size. It was almost a full-size sheet, hard to get into the frame, that I just cut to the sizes I need using only my mind. I don't like to show that kind of thing out of courtesy for you viewers out there without psychic powers. I also picked up another set of drawer slides. These are 18-inch. Yeah, they're 18-inch, 450 millimeter, and good to 75 pounds, 34 kilograms. They're also Fabricating on Chine, which I think means made in France. For that added touch of class, I got the self-closing ones. These draw themselves back in slowly as the drawer closes. I'm sure you know them. But do you know how they work? Pretty clever. These self-closing mechanisms, there are a handful of ways to do this because, well, you know, patents. But let's have a closer look at this one because, well, you know, self-closing, to me, is a bit of a lie. They don't close themselves. You're still the one closing the drawer. It's just that some clever person made you put in the extra energy up front when you first open the drawer, and the drawer slide is saving that energy for later, for when the drawer closes by itself. When you pull the slide open, in this case, you stretch a spring. Close to the end of that spring stroke, the slide trips a little lock. That lock holds the spring stretched. It also detaches the slide from the spring mechanism. You can see now the whole contraption is sort of cocked and ready to fire when the drawer comes back and you want it to close. When you're out here, when you've pulled the drawer open and you've sort of cocked and locked that spring, you feel none of that spring force on the drawer itself. It's not like a slingshot. If you were to let the drawer go, it would just break its way through your kitchen wall. Now when you come back, there's a little dog on the slide that trips that lock again and re-engages the slide. That reattaches it to the spring and pulls the drawer home. Now the reason it doesn't just like slam itself back home is because opposite the spring, hopefully you can see that little small diameter wire, in this housing would be what's called a viscous damper. Or if you're watching this in the 1800s, it'd be a dash pot. It's basically a baby hydraulic cylinder that's really leaky, full of some kind of grease, and when the piston gland is pushed against it, because of that spring force, the grease can only get past that seal, so fast, which slows the whole motion down. You, of course, are the one pushing the grease to the other side of that damper when you first open the drawer, along with that spring force. I mean, in this case, I don't know what's really in there. Maybe it's just air and a poor fitting O-ring. Maybe later I can dig one out of the drawer I just threw away and take it apart. For now, though, let's keep trucking with the build. You'll want to take your metal forming nice and easy. Keep it consistent. You don't want to go getting your drawers all up in a bunch. Because this material is so heavy, well, compared to the tools that I have to bend it, the sheet metal brake that you saw on the bench is leaving a bigger radius than I want at the bottom of all the bends. So I'm using this V-block essentially and a pointed tool to just sort of help bring those corners into a tighter radius. Just tidy them up a little bit. Now, I can't really go crazy with this thing. The eye's not long enough for the bend I'm trying to do. But so long as I keep these little tweaks within reason, I can clean the corners up a little bit better. So I think you saw me fold a hem on the 3 edges at the front, the 2 sides and the bottom. I don't want to cut the tip of my fingers off every time I need to get something out of the drawer. And the back looks relatively decent. Not quite there yet, but good enough for now. So my target was 12.2. I've ended up with 12 and an eighth. That's 125. So I'm a little shy technically. And although I'm a very big supporter of winging it, I donate money every year and even have a bumper sticker. When it comes to bending stuff, you have to have a drawing, no matter how rudimentary it might be. In this case, the overall dimension isn't really that important. I'd just like it to match the width of my welding cart. But the next couple of parts, the drawer and the top, need to be right on size in order to work properly. I've got sort of a stack up to worry about between the two sides, the drawer, and then the two drawer slides that fit between them. If it's off, the drawer could bind. So before I make the actual drawer, which I'm going to do next, I'm going to compare the dimensions of my layout lines to what I actually ended up with. Basically, I'm going to course correct. Okay, not too bad, I don't think. If these bends don't look super straight in the video, it's lens distortion. Anyway, this would be the moment of truth. If all went well, I should have 1 inch clearance between the two. Right on the money. I'm as shocked as you are. So the slides would fit in here. I think I'm going to install those before I weld the seams. So the rivets appear to clear the slide, but for good measure, I think I'm just going to... So I have the drawer in. I did the same exact thing, 3 rivets, in this case into the moving rail. I did have to move one. I don't know if you can see the hole back there. I had one at the back, the front, and the middle, but that interfered with the closing mechanism, so I moved it forward a bit. This drawer is never going to see 75 pounds. You'll be lucky to see 10, so I'm sure that's fine. Opens up all the way and closes by itself. I also left a bit of a gap at the front. It's not much, but once the drawer face gets on this drawer, the drawer face will be larger. It'll be the same size as sort of the casework here. When the drawer closes, because of that gap, the drawer will stop about there instead of going all the way back. That's just to give me a little bit of preload on the drawer when it's closed. I think it'll have a little bit better quality feel. I'd much rather have it biased closed than having left a gap and maybe it gets full of grinding dust and that sort of thing. Plus, I think it'd look better. And last, I need to make the top. This will have bends on all 4 edges. It'll close off the top and, as you saw earlier, serve as a tray area. Now, this is probably the hardest part to make here. These dimensions need to turn out almost perfect. If this top tray ends up a little bit short, it'll pull the sides in and potentially bind the slides. If it turns out a little bit long, it'll spread the sides out and maybe do the same thing. To be honest, I don't know how much play I have in those slides, how much they can absorb some of that variation in width, but I guess there's only one way to find out. I've cut it to final size, trimmed the corners, and on this piece I've scored the bend lines with a cutoff wheel. Hopefully that might help to keep the bends to size and make them a little easier to work with. Then we just bend it like Beckham. Sorry about that. I didn't mean to kick that out of the shot. So let's try the fit up. This thing's getting pretty heavy. It's just going to need a little bit of massaging as I work my way up to the top. I'm going to start to tack weld the drawer, bring that into square. Right now the bends are still a little bit open. That'll pull on the slides a little bit and I can start to bring the top in. Alright, well the drawer is finally on the cart. It's welded in place. I've opted to float it a bit, about 1.5 inch or 40 millimeters. Essentially the same size as the tubing. Again, just to break it up a little bit. Before we have a look at the other side, I've also added 3 hooks under the welder shelf. For now, I've put them inside the footprint of the cart. If I ever get a cooler, I'll have to move those hooks outboard. And here's the other side. I've added 8 small pieces of angle iron, 4 per cylinder, and 4 eyelets, like little D-rings. I plan to put 2 bottles on this cart, 2 cylinders, one argon and the other a 50-50 helium mix. So I've got sort of 2 bays, one for each bottle. I plan to use a small hold-down strap, and I can run it through those rings and really cinch the cylinders down solid to the cart. So I think it's time to paint this thing now. Color is a tough one. Left to my own devices, I think I would probably make this matte black. You know, kind of like that muscle car look. I have a few rattle cans of that stuff too. But if I make it matte black, I won't be able to show this cart to you. It'll just disappear into the darkness that is my garage. The obvious out here is to make it bright yellow. I may have burned that bridge on this channel. So I think I'll just dig through the paint cabinet and see what blue. Made the darn thing blue. And I'll be honest with you, I'm not quite sure how I feel about that. The whole combination is just a little loud. What's one more thing on the long list of poor life choices I've made till now? Rivets don't seem to get much love these days. Not as much as they used to anyway, but I'm still a fan. In this build specifically, I'm using mom rivets. First, as you saw, to mount the drawer slides, and now to keep the panels in place. Mom rivets, right out of the box, aren't much different than regular rivets. But over time, they have the potential to develop much stronger bonds than pop rivets, which can sometimes end up getting fat, watching too much TV, and generally disconnecting. I think I mentioned this. I wanted to add a solenoid to control the city water that's cooling my torch. I found this one. I think it's from some kind of industrial dishwasher maybe. I was trying to be optimistic because the port sizes are the same sizes as my torch, but if I run water through here, I get a lot less out than I was expecting. So there must be quite a restriction in the valve area. Also picked up a flow meter. This was just a few bucks, I think, off of Amazon, just to give me a visual indication that everything was actually working. The idea was to add a power switch to the front of the cart that both turned on the welder and actuated the solenoid. That way I'd always have water when the welder was on. But I think I'm going to save this for another time, something like an add-on to the cart. Though I did add a front mount power switch. It's just a lot easier turning the machine on from the front. By the way, this thing is a Kedu. Kedu HY56. They're like the start and stop switch you usually see like on a drill press or a belt sander. I thought this had the right power rating for the machine, but it's 35 amps if you're running at 120. At 220, it's only 20 amps, so no good for this project. This, I believe, is from McMaster. It's one of those build-a-switch things. Never remember how to get these apart. These are the type of controls I'm using on my CNC router. You buy a mounting plate that takes, different style of switch. If you need like a normally open or a normally closed, some kind of toggle switch, they have different flavors of these. They snap into the chassis somehow. And then you can add the, whatever style button you like. This is like a push lock switch. You push it and it stays on. Push it again and it goes off. Now to use something like this though, to control the amount of power that the welder is using, I'd have to go through a contactor, some kind of a big relay, and that would just get too expensive. So I ended up using like a drum switch. I'll show that to you on the machine. And lastly, I picked up some plumbing. I got a dual flow meter. This is from HTP. They're not too expensive if you compare them to 2 single flow meters. But this will go into the argon tank and give me 2 outputs. One will go straight to the welder to feed the torch, of course. And the other side I'll just leave free for now and have it available if and when I need back gas. As you saw, it's a 2-tank cart, and to be able to select between the 2 tanks, I got this Y valve from McMaster. I'll feed argon in one side and the 50-50 mix in the other, and then I can select between the two without screwing around, moving regulators and hoses around. This is panel mount. I'm not going to mount it just yet. I'll plumb it in temporarily, but I forgot to get some elbows. I got the hose nipples, but as you can see, it gets a little awkward. It's sending my hoses in every direction. I'm going to get a couple of 90-degree elbows and just bend these connections so everything's going the same direction. Then I can panel mount that nice and neat and hopefully have real quick, easy access to both welding gases. If you think you want to install a switch, just wait for the paint to dry. Make sure you know what you're doing. Now, I can't officially endorse this. If not done correctly, it's, again, not the smartest thing in the world to run power through a welding cart. In this case, everything is hard mounted inside a steel tube. All of the wiring is inside a plastic conduit. It's all tied down. Really convenient for me, but just be smart if you want to try something like that yourself. Maybe get someone qualified to do it, or buy a welder with a switch on the front. I added some filler rod storage. It's 4 pieces of thin-walled aluminum tubing. There's 2 screws holding it to the frame. Closed containers are probably a smarter idea, but I don't buy that much filler rod. I'll buy like a fistful from the local welding supply when I'm running low. Vertical to me is just a little more space efficient, though the organizer or the rod holder doesn't reach the bottom of the cart. The idea there is just let dust and dirt fall through and not really accumulate at the bottom. If you did close that off and it was, 24 inches deep, you could bet your bottom dollar that when you start fumbling like one of your TIG torch parts, it's going to end up deep down in there. They're tacked together as one unit, again, and there's just 2 screws going into the frame. To keep them from rattling around, I use just pieces of sponge and pack them down in there. I rounded all the edges over, but I do plan on adding plastic trim, especially on these 2 outside corners. And I plan to do the same thing on the edge of the drawer at the top of the tool tray. What I mean by that is this plastic kind of trim you get with bandsaw blades. I could have sworn I kept a lot of this stuff around, but I can't find it. But next time I buy a saw blade, I'll add the trim. As you can see, I've also populated the drawer with all the TIG stuff I had stashed all over the garage. No kidding, other than having a welding cart finally for the HTP, the drawer is probably the thing I'm most excited about. Having another drawer down here, golden. It's the little things. And here's the Y valve for now, selecting between the 50-50 mix and the straight argon. Just turn on the right bottle and it's easy enough to pick which one you want to use. Again, this is only temporary until I get some other fittings to clean this up. I don't expect to keep this hanging here for more than 4 or 5 years maybe. Well, I think that's about the long of it. I'm glad to finally have a spot for the TIG welder. The color choice probably won't rank among my finest achievements, but so far anyway, it's not triggering my auto-darkening helmet, so I suppose it'll do. Better than keeping the HTP on the floor at any rate. As always, it was a pleasure having you, and maybe next time, I can get into some of the more advanced features of the cart, like keyless entry and remote ignition. Thanks for watching.